In Step 2 of exercise number 6, the following actions have to be implemented to complete the machining of the outside shape. During this step, you will see how making changes to the tool definition has an effect on the technology wizard. Later, the material boundary feature is used to define the machining geometry for the final outside shape. First, you have to define the rough and finish machining of the original outside shape. Add a new iMachining 2D operation. In the SolidCAM Manager, right-click the operations header and choose 2D iMachining from the Add Milling Operation submenu. The iMachining operation dialog box is displayed, and the default iRough is used for technology. On the Geometry page, click the New button to define the machining geometry for the original outside shape. For this operation, the geometry is defined as an open pocket with island. In the SOLIDWORKS graphics area, pick on the bottom edge of the stock model as shown. Select Auto Constant Z in the Chain section of the Geometry Edit dialog box to close the chain. When the confirmation message OK to accept is displayed, click the Yes button to accept the selection. The chain icon is displayed in the Chain List section. Right-click Chain 1 and choose Mark Chain as Open. This will enable the tool to approach from outside and start machining from this chain. Next, pick on the bottom edge of the target model representing the original outside shape as shown. Select Auto Constant Z to close the chain, and then click Yes to confirm the chain selection. The geometry is defined. Click OK to confirm the geometry selection and exit the Geometry Edit dialog box. Switch to the Tool page and click the Select button to display the Choosing Tool for Operation dialog box. In the Part Tool table, select Tool number 2, the 12.5 mm end mill. This milling tool has a 24 mm cutting length, 5 flutes, and a 45-degree helical angle. Click the Select button to choose the tool for the operation and exit the Part Tool table. Switch to the Levels page. To define the milling levels, first click the Upper Level button. In the SOLIDWORKS graphics area, select the top face of the stock model as shown, and then click OK to confirm the selection. Next, click the Pocket Depth button and select the bottom edge of the target model to define the machining depth. Click OK to confirm the selection. To perform machining deeper than the part bottom edge, enter a delta depth value of -0.76 millimeters. Switch to the Technology Wizard page to view the cutting conditions. Looking at the step-down output grid, the wizard automatically calculated 2 steps to achieve the total depth. The ACP indication is 2.2 and the field is painted green for good stability. With a machining level aggressiveness of 6, note the output cutting data values generated by the wizard. Looking at View 1 and View 2, the following sets of data are provided based on the tool information and milling levels defined for the operation, as well as the machine and work material definitions. It is important to note that selecting a tool with a different diameter can dramatically alter the cutting conditions being calculated by the Technology Wizard. For example, switch to the Tool page and click the Select button. In the Part Tool table, select Tool number 1, the 16 mm end mill. Currently, this milling tool has a 24 mm cutting length, 5 flutes, and a 45-degree helical angle. Click the Select button to choose the tool for the operation and exit the Part Tool table. When selecting a tool with a different diameter, if you are using any advanced features or controls, you will be prompted to recalculate certain values within the operation. The individual parameters whose values are calculated based on the tool diameter are covered in greater detail in exercise number 7. Keep in mind that it is recommended to click Yes. Switch back to the Technology Wizard page. Looking at the step-down output grid, the depths remain the same, but the ACP indication is now 1.7 and the field is painted yellow. Looking at View 1 and View 2, you can see that selecting a tool with a different diameter has an effect on the output cutting data values generated by the wizard. Editing certain parameters of the current tool can also dramatically alter the cutting conditions being calculated by the wizard. For example, switch back to the Tool page and click the Select button. Under the Topology tab, keep the diameter value of 16 millimeters. Edit the remaining tool parameters as follows. Total length, 90 millimeters, shoulder length, 40 millimeters, and cutting length, 35 millimeters. Changing the cutting length can have an effect on the step-down output grid. The wizard uses the cutting length to calculate if multiple steps are needed to achieve the pocket depth. Set the number of flutes to 6. Changing the number of flutes will have an effect on the feed rate, the ACP indication, and possibly the step-downs in automatic mode. Switch to the iData tab. In the Tool Materials section, select Premium Carbide at 150%. Changing the tool material will affect the maximum cutting speed calculated by the wizard and the associated spin and feed rates. In the Machining Level section, select a default level of 8. Changing the default level will affect the output cutting data by positioning the slider to the machining level assigned to the tool. Set the helical angle parameter to 60 degrees. Changing the tool helix angle will affect the ACP indication regardless of the calculation method and possibly the step-downs in automatic mode. Click the Select button to choose the tool for the operation and exit the Part Tool table. Then, switch back to the Technology Wizard page. Based on the current tool information, the wizard now calculated one step-down to achieve the total depth. The ACP indication is 7.1 and the field is painted green for good stability. The machining level slider is now positioned at level 8 based on the default level assigned to the tool. To compare the output cutting data values with those prior to editing the tool, reduce the machining level slider to 6. Looking at View 1 and View 2, you can see that editing the current tool also has an effect on the output cutting data values generated by the wizard. For the purpose of this exercise, change the mode for calculating step-down to user-defined. Using number of steps, enter a value of 2 in the input field text box. It is important to note that when selecting or reselecting a tool from the Part Tool table, any Technology Wizard overrides will be cleared on both the Cutting Conditions and Modify Cutting Conditions pages. For example, switch back to the Tool page once more, and then click the Select button. When the Choosing Tool for Operation dialog box is displayed, simply click the Select button to choose the same tool for the operation and exit the Part Tool table. Then, switch back to the Technology Wizard page once more. To ensure all cutting conditions remain safe, you can see that they are automatically reset to the defaults after selecting the same tool. In SolidCAM 2012 and newer, you can choose to keep all cutting conditions when selecting the same tool. You can enable the Do Not Reset Cutting Conditions when selecting Same Tool option either per project on the iMachining page of the part settings, or globally on the iMachining page of the SolidCAM settings. However, when using this option, you should be aware that the cutting conditions are kept and that they may no longer be optimal or safe. At this point, the operation can be calculated using the default cutting conditions generated by the Technology Wizard with a machining level aggressiveness of 8. Name the operation iRough Outside Shape. Click the Save and Calculate button to add the iRough operation to the CAM tree and calculate the iMachining toolpath. Click the Simulate button to display the simulation control panel. Using the default HostCAD simulation mode, click the Play button to show the wireframe toolpath on the model. The tool approaches from the outside, moves around the part model, and performs the rough machining of the original outside shape. Close the Simulation Control Panel with the Exit button to display the iMachining Operation dialog box. To perform the finish machining of the original outside shape, you have to define an iFinish operation. Create a copy of the current iMachining operation. Click the Save and Copy button. The current iMachining Operation dialog box closes and the copied operation automatically opens. Click the drop-down menu under Technology and change the operation type to iFinish. The copied machining geometry, 16mm tool, and milling levels from the previous iRough operation are used for this iFinish operation. On the Technology Wizard page, The default cutting conditions are used with a machining level aggressiveness of 8. On the technology page, the step down and cutting angles generated by the wizard are shown. By default, the wall island offset is set to 0. Switch to the IRES Data tab. The previous iRough operation is selected as the parent operation by default, and the fields are automatically filled with the 3 important values needed for calculating rest material. At this point, the operation can be calculated, and the iMachining toolpath can be viewed on the model. Name the operation iFinish Outside Shape. Click Save and Calculate, and then click Simulate. Click the play button to view the iMachining toolpath at work. The tool approaches and performs finishing of the original outside shape by removing the 0.24mm offset from the walls. Using the exit buttons, close the Simulation Control Panel and the iMachining Operation dialog box. At this stage, the machining of the original outside shape is defined, and changes to the tool definition were shown, having an effect on the technology wizard.